Yeah, good evening. So we will be discussing some of the concepts regarding production planning and control. So this is the continuation class. This is the session, live session 10. So my name is Rakesh. I am from IIT Bombay. So in this session, I will be discussing some of the concepts and some questions related to this uh, production planning and control, and which scheduling is one of the part. So so I will be discussing these concepts by using some say some examples, so in that way it will be easy to understand. So let me start with an example. So this scheduling in broad sense is to, so there are some n number of jobs and n number of machines, so we should
Sir,
find an optimum.
excuse me.
Yeah, tell me.
Sir, will there be any recordings for these lectures?
Yes.
So actually, the site is not showing the recordings of these lecture series.
You better ask once you can mail to the coordinator. You are
Okay,
registered in that, you can mail to coordinator, she will provide you the link for that.
okay.
Okay.
Thank you, sir.
Yeah. So as I'm saying, so there will be some. We need to find an optimum way to organize these number of jobs in certain machines, so that the time will be our whatever our requirement. Suppose if you want to finish certain jobs in certain times, so we should have a certain planning for this. So there are several number of ways in order to meet several number of requirements. So we'll be discussing one by one, and we will seeing at the end what is the conclusion of all these methods. So let me start with one example. Suppose we have two. We let us start with the some basic one. So the first model. So the first model will be processing processing of n jobs on two machines. So I'm writing machines a shortcut of m/c. Okay. So in this we will have n number of jobs, but only two machines are there. So there are some certain cases, n jobs with two machines, n job with three machines, then n jobs with n two jobs with n machines. So there are certain models, but for gate there are so very few number of models that you need to cover. So let me take an example. So these are the jobs, that is job one, job two, job three, job four, and job five. So we will have machines, machine one and machine two. So the numbering, the values that are given are 8, 10, 11. So this is the problem that was given to you, and so they can ask several number of questions. So one question is, what is the sequence of jobs? Then they can ask what is the total time for completion of these jobs. Then they can ask you what is the ideal time for each machine. Okay, these are the type of questions they can ask in this simple problem. So let us proceed. So first, uh, we need to find the sequence. So the sequence we can find using, so there is this method. You can, so you can write boxes like this for number of jobs. So we have 5 jobs. I have done 5 jobs. Then you place the machine one, machine two. Then we should see first thing is we should see which is the least, which job consumes the least amount of time in each machine. So so if you see this 7 in machine 2, it is the least time, and here 7 is the least in machine 1. That is the job 1, job 4. Sorry. So we should write job 4 here because it is having least amount of time in machine 1. Similarly, job 1 on the machine 2 side we have to write. Okay. Then we have to cancel this because the job is done. Then we have to see the next minimum. So here I can see 10, 9 is the next minimum, and which is in machine 2. So I have to write J3 here. Then I have to cancel this. Then I have left with 2. One is J2 and J5, and J2 is the minimum because it has 10 in machine 1 side. So J2 will come here. So obviously the only job left is J5. So this is the sequence you have to follow for further steps. So the first question is done. So we are going with least amount of time that is required to finish a certain job in respect to machines. Then this is the first. This is the first one. So we we call this as optimal processing order, OPT, OPO, optimal processing order. Okay. Then comes to the second step, that is processing of jobs. So for this we have to construct a one tabular column. So first task is done, that is finding the sequence. Now we have to find these two, total time and idle time. This will come in one go, that is we have to construct this tabular column and we can proceed with that. So for this we'll start with this optimal. The first column is optimal processing order. Then the next one will be machine 1 time. Then machine 2 time. So in each machine we will have in and out, job loading and job unloading. Okay, this is the number of columns. Okay, so these are the so this is the setup. So now we have to give the sequence. Okay, so now give the sequence, that is so in first one is J4, then J2, then J5, J3 and J1. Okay, that is the sequence you have to follow. So don't be in hurry while solving these questions. Be patient. Do every step. Don't miss any step. Because even if there is one wrong, everything will go wrong. So let us start with J4. You copy this. Then I will copy this in here.
Sir,
Yeah, yeah. Tell me.
are you using this by LPP method? Are you using this by LPP method, right, sir?
What is LPP? Can you?
Linear part programming,
No, no, no. This is very
like
simple.
on 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 operation research, what we have learned, like
So this is a simple rule.
Western. Okay, okay,
So this is like optimum processing order that we are creating. This is these rules are create this the whatever rule I told. These rules are like Johnson's rules that we use for scheduling. Okay. Okay. Let me fill out this first. So first one is machine one. So I will write. So I know the time. This values I will write directly. So first job is J4. Initial time will be 0. If it will be different color, it will be easy to handle. So first one is 0. Then J4 value for machine one. If you see that is 7. So the next loading time for this machine 2 will be the 7. Then this J4 value M2 is 8 minutes. So 7 plus 8 will get 15. So the next, if you come to J2, we have to directly put this value here. That is 7. Now we have to see the what is the value of J2 for machine 1. If you see J2 for machine 1, it is 10. So we'll add that 10, we'll get 17. Then in this, we have to see which is highest. Highest in the sense this 15 and 17. Whichever is highest, I have to fill that here. Suppose in case instead of 15, suppose if I have 20, I have to fill here 20, not 17. So that we have to take care. So now it will be 17. Then we have to see the J2 for M2, so that which is 12. So 12 plus 17 is 29. So similarly, the other same thing, I will take this value here. I will add this JFA value, comes to 31. Now I have to compare this 31 and 29, whichever is higher, I will keep here. Then I will add the job time for the machine 2. So now see in this we have 42. So at the 42 minute, if I say, but the time required for completion of J5 in M2 is 43. So I can load the J3 job in M2 only after 43rd minute. So that's why I have to take here 43. That's what I'm explaining previously. So then we will add the time for J3 job in M2. We'll end up with 52. Then finally 42, the J1 value, 8 minutes, that is 50. Then again we have to see the value. So here we have 50, here 52. So we have to load at 52 minute only. Then we'll add the time. So total we are getting 59 minutes for completion of all these jobs. So the questions that I asked is what is the total elapsed time? Elapsed time, that is 59 hours. It is given in hours, so 59 hours is the total elapsed time. This is the second one. Then we have to see the idleness time. Okay, this idleness comes by seeing these two values. Machine one will always be completely filled, because we will not see idleness 7 7 17 17 31 31, because it's the machine one, so every job will get loaded in this. But when come to the machine 2, it has to wait for the 70th minute in order to load the job, even it is free at 15th hour. So now the idle time for this job 2 will be 2 hours. Similarly here, but if you see here, there is no waiting time for these two. So 0, 0. So the total waiting hour is 4 hours for machine 2 and 0 hours for machine 1. So this is the simplest case, that is processing of n jobs. Processing of n jobs in 2 machines. So what are the questions that I have asked it earlier? The sequence, that is nothing but optimum processing order. The total time or the elapsed time, that is 59 hours. And what is the time for each machine? So M1 is completely, there is no idle time, so 0 hours, and M2 is 4 hours. So these are the main questions that you can ask very simply. This is a simple model in this case. So next, let us move to the next part. So in this case, so I will give an example. You can try out from your side. So now in this time we have 6 jobs. Okay, now we have 6 jobs. These are the values: 14, 10, 11, 16, 14, 18. Then okay, just note it down, then and solve it later. I will give the answers for this, then you can also check it. So the total processing time or total time is 92, and machine 2 idle for 11. So just note it down. Then we can move to the next part.
Sir,
Yeah.
here in job 5 and job 6,
Yes, yes.
job 6 and mission 1 18 and 16, and job 5 mission 1 14 and 12, sir. Here,
Yes, yes.
Yeah.
So,
for job 5
okay.
on mission 1 16, for example,
Uh-huh.
on mission 2 job 5 is 18.
Okay.
Now job 5 and job 6 both have the similar time. Which
Okay.
job take first?
So, yeah, this scenario will come, but generally in GATE, I don't think they will ask this, because
Yes.
in that
Today
case,
mark test the question is there.
okay, okay. So one thing you can see is, in that case, suppose I have 6, right? You will get 2 models. In one case, you will get, suppose if I take 5 here, which are having same values, I will take 6 here. So in that case, you have to two values, and you have to see the both the values, and at the end, the total time you have to see whichever is giving lower total time and lower idleness, then that model you have to select. That is one way of doing it. The other way is you can see the, suppose, as you say, suppose there is a conflict between this job 5 and job 2. Suppose in case of, see, 12 12 is there, assume. So in that case, you can see the time in M1 also. So accordingly, you can allocate. Okay, suppose here I have 12. Here also I have 12. In that case, you have to see the other values. So here I have 12 in M2, whereas here I have 10. Okay, then I will take the M2 value first, then I will give this for the other one.
Okay, sir.
Okay.
Which one has the total minimum time? That
Yeah.
job will
In
first.
yeah, in principle, that is the one. whichever is giving the minimum total time is, that of course that will be the optimal processing order, because that is the one which is giving you the less total time for that. So
Okay.
so in this we have taken everything for granted, but there are some assumptions which they might ask you in theoretical type. So in the assumptions will be one thing is this loading and unloading times are we didn't consider. The minute it was completed, it was loaded, which is not possible in uh, actual cases. That is one. Okay. So the second one is so once the job is loaded into the machine, by any chance we should not take that and use in some other jobs. So we have to wait till the completion of the uh, that job, that particular job. So that is what the assumption that we are making while doing all these things. So the third one is this processing time and processing order are independent. Okay, so there is no restriction that is binding you in order to relate these two things. So you have a chance, you have a free time, you have a like independence in that for choosing the processing time. So you don't have to worry about the processing order or vice versa. So these are the some of the assumptions that we use for making these type of decisions. So let us see the next model of the similar kind, in which so the second I can say, so the second model will be same processing of n jobs in 3 machines. So in the previous case it was 2 machines, but now it was 3 machines. So in this type of questions, you have to remember one this Johnson's rules.
So can you show the answer for the previous one?
Yeah. It's
Okay.
92 and so this Johnson's rule you have to remember that is, suppose if you have 3 jobs, say job A, job B and job C, then the minimum in machines, the minimum in machine B, yeah, so the minimum in machine A should be greater than or equal to maximum in machine B. This is the one rule. The other rule is minimum in machine C should be greater than or equal to max on machine B. So in these two, any one, if it satisfies any one, that is fine. You are good to go with this type of rule, with this type of process that I am going to explain you. Okay, this you have to keep in mind before applying this type of process. Okay, so let us. I will give the sum first. This is the rule that you have to keep in mind before proceeding anything. So the question is, job and machines. So in this case we have 3 machines. And we have around 6 jobs J2, J3, J4, J5 and J6. So we have values 10, 14, 15, 11, 12, 11, 17, 13 and 14, finally 14, 12, 15, 16, 12 and 16. This is 12. So these are the values we have. So in this type of questions, what we do is we convert this into these 3 machines to 2 machines theoretically. Then we will get the sequence, this job sequence. Once we get this job sequence, we will again we follow the previous method itself. So for converting, we have to convert. So this all 3 machines, they are converted into machine A and machine B. Okay, this machine A is nothing but machine 1 plus machine 2, and machine B is nothing but machine 2 plus machine 3. Okay, so if you nothing, we will just add these values. That's it, nothing else. So let me add it. Job 1, job 2. So we will get 22, 26. Okay, this is the value. These are the values that you get when you do this uh, this this type of conversion. So now we will follow the same method in order to get that sequence. So we have to look for this the smallest value. Okay, here I'm getting 22, the smallest one. Then rest are like more than 22. So this is in J1. So I will keep here. So this one is done. So the next smallest value is yeah.
The previous conditions not followed satisfied.
Yeah, they are not satisfied in this case.
How we can proceed further?
Uh, Ideally, they have to satisfy this, but they are not satisfying in this case. So I will come to that part. Just wait a second. We'll see what happens if we go through this process.
Okay, sir.
So J1 is done. The next minimum value will be is 25, if you see, which is on B side. So that is J2. So the next minimum value is 26. So now we have two 26s. One is here and one is here. Okay, J3 and J5, J6. Yeah. So in this, if you follow this, you will get two models. In one case, we can take J3. In other case, we can take J6, the first one. Then we have to see all these models, and we have to see the processing time, which is giving the minimum. So instead, you can see this value, this 30th value. So we have this here. We have 30, and we have 31. So since it is taking much time in this J3 value, see in machine MB value or machine B value, so we'll take this, so it will be completed early in the first MA value. So we'll considering J3 here, then followed by this J3. If you write J3 here, this will be done. So the next minimum value will be 26, which is an again J6. Let me take this value. Then again we'll have 32, 32, 31 we have minimum value here. Then J5. So this is one sequence we are getting. So similarly, you will get the other sequence also. And you can work out which is giving you the minimum this value. So have you verified these values 22, 27, G26, or are you just following? I think there is some mistake, but this is the way you generally allocate the things. So whatever we do, finally we have to get this optimum processing order. Once we get this optimum processing order, then the rest of the process is similar. That is, we have to keep machine 1, machine 2, machine 3 in out, in out, in out. So here we'll have jobs. That the whatever the sequence you are getting. So if you do correctly, the sequence will be 1, 5, 6, 4, 3, 2. This is the sequence that we get. No need to worry about the sequence. You can find that sequence easily. But once we get the sequence, that is one where we should be careful. Sequencing. Once the sequencing is done perfectly, then we have to take care of these values that we come. I'll just write fill some of the values so that we'll get that concept. So initially it is 10 minutes. Directly it will go 10 minutes. So this is the sequence. Then again directly the 10 will come here. So still now there is no. So as I said, we have to see these values. Whichever is higher, that we have to keep here. Similarly, 26. So this is 36. Sorry. So we have to see this 35, 36, 36 here. So we are keeping 36 here. Similarly, the next will be the. Just check these values. and do yourself, then you'll get. Maybe I'm writing something wrong here. 35, 51. Then we'll get 51 here, 61. So don't worry about these values. Just see this where you should be cautious. So one thing is this optimum sequencing. The other one is these values. We have to see this is one value and this is the other value. Whichever is highest, that should come here. So in this case, if you see here, we got only 48, but here we are getting 51. So that will come here 51, so that the machine will be ideal for 3 hours. 48 to 51, it should be ideal. Similarly, you have to see. So here there is no ideal time. If you see 22, 22, 35, 35. Suppose in the next step, suppose it is 51, but you are getting some 53 here. I'm just writing randomly. So it has to wait for 2 hours. So the ideal time will be 2 hours for this machine, for this job. Similarly, you have to sum up all these jobs. Similarly, you have to sum up all these jobs in order to get this ideal time for this. So whatever value we get at the end of all these things is the processing time that we get here. So in this case, you will get like 110. Okay. Just I will give the answers for this similar question. Just verify yourself. So one thing, the processing time is 120, 110 processing time. The second one is this ideal time. So the first one, the machine 1 and machine 2 will be like 0, but the machine 3 will be just 3 hours for machine 3. The other will be 0, 0. This ideal time. See the value, just check yourself. So this is one more method. Then we'll come to the third case. I will not explain this case because it is, I think, you just know that this type of model exists, but no need to worry. So the thing will be so previously we are following 2 machines but n jobs, but in this the case is reverse. So there are only 2 jobs but there are n machines. Okay, so these type of problems do exist, but you don't need to worry about this. So in this case, we'll just construct one grid and we'll assign the values accordingly. In which case we will follow this same process. Then we will get these values of what is the processing time, what is the idealness, everything. Okay. So in this case, the everything will be reverse. So in previous case, machines are like we'll get job 1 and then machines will be counted like 1, 2, 3 and so on. Then we will get this processing time accordingly. Similarly, job 2, what are the machines available? So whatever the machines available in this case will not be available here, or maybe, but in the different format and so on. Similarly, the processing time. Okay, so I'll just explain the model. So we'll, as I said earlier, we will construct a grid like this. And we'll assume that J1, whatever the job that is processing, will take x-axis. So in this, we'll solve the J1, whereas in the y-axis, we will solve J2. Okay, and we will keep the values that machines A, B, I gave 1, 2, 3, 1, 2, 3, 4, 5, and so on. Similarly, in other case, 1, 2, 3, 4, 5, 6. And then I will arrange this grid in a certain manner. Suppose this is 0 and this is 0. So as I'm moving further, I will get. I'm just writing in a sequence of multiples of 4 and so on. Here similarly, and then now suppose if I say this job v suppose job this one will take this much, and then job 2 will take so I have to see the timings. So this is job 1. So suppose if it takes 4 8, so I have to remove this 2, I have to place 2 here, and then I have to hash it. Okay, similarly I have to do in the vertical also, whatever the time it is, what is the in time and what is the out time, and then we will draw a one line that is going. No need to ever, just I'm just explaining this model exists. You just know that this model exists, so no need to worry about it. So if there is any line passing, you just know about this these things only. So if there is any line passing through 45 degrees, so that is nothing but so both the jobs J1 and J2 are in processing. Okay, both the job and J2 are processing in respective machines, and we should not. This should so what we try at the final goal is we'll try to keep it this at 45 degrees line only. 45 degrees line only. We will not use much. Will not much use this vertical or horizontal line in constructing this figure. Okay. This is one way of doing this n jobs and n missions. No need to worry about this. I'm just explaining you for the sake of knowledge. Then these are like the basics of this scheduling. What actually may not be asked in GATE till now, but whatever I will discussing right now will be asking in GATE. So they cannot easily ask a 2 marks question or 1 marks question based on this. So there are some scheduling rules. Okay, this scheduling rules, one is shortest processing time. The other one is the longest processing time. Then first in first out, earlier due date, random, and then sixth one is last in first out. Okay, I think you might be familiar with these type of things, first in first out and last in first out. So if we take example of lift, so the last in will be the, so I can give example as lift in this case. So whoever enters the last will leave the first, ideally, if they are going to the same destination. So first in first out, whoever comes first, they will be served in most of the scenarios. In daily life, we mostly come with first come first serve, like in that case. Then the other thing is shortest processing time. So these are very important for GATE. One is the shortest processing time, and the other one is the earliest due date. So there are questions on these two models. So I'll come one by one. So the principle remains the same. So whatever we schedule these jobs, previously we are following some empirical method of taking least possible processing time, and we are sequencing the jobs. But in this case, we will sequence the job according to this processing time, according to the earliest due date, or according to the first come first served, or random. And each method has its own advantages as well as disadvantages. So according to that, we have to select this method. Okay. So first, this shortest processing time. So I will use this same whatever sum I am using for all the 6 cases are important cases in order to reduce these conclusions. So let us start with this first one, that is shortest processing time or SPT. Okay, I will give this take this sum. You can note it down. I will give the values directly. Suppose I have some 5 jobs. This is processing time, that is PT, and due date. So the values are 8, 7, 9, 10, and 6. Then 12, 10, 15, 20, and 18. You can note down these values. So now the first model is shortest processing time. So if you see here 8, 7, 9, 10, 6, you can directly write this sequence. So now sequence wise I am writing. So first the minimum job is E, which is having a processing time of 6. The next will come this A, which is having, sorry, B, which is having 7. Then comes the A, 8. Then C and D, which is 9 and 15. Okay. Flow time is nothing but the addition of the next. Suppose the 6 is the first time, so the next one will be 7. 6 plus 7 will get 13, and we'll add up these things. Okay. Then the due date. So we have to write this due date in order to calculate how much each job is getting delayed. Okay. Now, if you see the first job, that is E, the flow time is 6, but due date we have 18, so it is completed well before. But the second it is 13, but due date is only 10, so we have 3 late by 3. Similarly, the other cases. 20. So if you take the final summation, so this sum you would get 40 for this. The flow time should be 110. And this due dates we have 75. This due date is not required, no need to write. Then this lateness is 47. This is like total job lateness for the completion of whole time. Okay. So now by all these values, that is like flow time and job lateness and processing time, we'll have some parameters to measure. So one is this average completion time, which can be asked easily. Average completion time. So that is nothing but summation of flow time divided by number of jobs. So we will be getting okay. This is the 22 days is the average completion time according to this shortest processing time rule. Then we will have the other things also, that is yeah.
Sorry to interrupt. Like I just had a thing, sir. Like I just had to join late due to. Can you kindly tell what happened? Like, tell me, sir, what are the topics we have done?
So we are just starting with the we are just discussing some of the concept related to scheduling. So I have discussed some two models, some n jobs, two machines and three machines. Then I'm starting this some of the rules, that is shortest processing time, uh, then earlier due date. So these are the models. So this is the first model I'm explaining.
Okay, sir. Thank you.
Then comes the utilization. That is nothing but the total processing time divided by total flow time. So 36.3% is the utilization in this case. Okay. Similarly, we will have average number of jobs waiting in the system. This is nothing but total flow time divided by total processing time, which is the inverse of this utilization. 2.75 jobs are waiting in the system at a given instant. And the final parameter is the average job lateness. This is nothing but the summation of total job late, that is 47 in this case, divided by number of jobs. That is 47 divided by 5, that is 9.4 days is the average delay. So these are the some four parameters that we measure for each case. So this is for the SPT, that is shortest processing time. Similarly, we'll do for the other one. Longest processing time. So in this case, similar same thing we will do, but instead of taking shortest, we took here 6, 7, 8. We'll take the reverse in this model. That is, we'll take D. We'll take D, C, A, B, and E. Okay, according to the sequence, that is 10, 9, 8, 7, 6. So this is the job. This is the processing time. The rest will be same. You can do this flow time. You have to add this due date, then only you will get this job late. So no need to write. I will give some examples after some time. I will just write the final values just for comparison. So we'll have 5 jobs. Total processing time will remain same irrespective of that, but this flow time will change. 130. No need for due date. Then the average tardiness is average job lateness is 65. Whereas in SPT we'll have only 47. But here we have 65. But to see this flow time is 130. In SPT it is 110. Okay, these values are changing according to this the model we figure out. Okay, so I'm writing all these parameters that I discussed. First one is average completion time. That is ACT, average completion time. 30 divided by 5, 26. The other one is this utilization, processing time, some total processing time is 40, but our flow time is 130, so it end up 30.7. Utilization is 30.7, but here is 36.7. So in every part, this SPT is like better compared to this longest processing time or LPT. Then we will come average job waiting in the system is it is nothing but the inverse of this utilization. Then finally we have average job lateness. So you'll have 65 by 5. We have 13 days. So in most of the in all everything this SPT dominate this LPT process. Okay, this is one more. Then similarly you can apply the same principle for the other one also. That is the third one is first in first out. Same thing you have to do. So here you don't have to follow any rule. Whatever comes first, you will take it. That is nothing but A, B, C, D, E. No need to follow any rule. Directly you can take this. Okay, directly you can take the things directly. Then you can calculate. So if you do, you will be getting this. So this is something like this is in between this SPT and LPT. So average completion time is we'll be getting 24.2 in this case. So utilization is 33%. Then average job waiting time, which is inverse of this utilization, is 0.025. Average job latency is 10. Whereas if you see here, we'll have 13. It's more than we have 3.25, where we got in FIFO is 3.025. Utilization is 30%. In this we got 33%, and 26 days for the completion time. Here we got 24.2. So it is like in between this SPT and LPT. So these are the three models. Then comes the fourth model, earliest due date. So here you have to follow this similar principle, but suppose instead of job flow time, we have to concentrate on this due date. So the sequence should come from the due date. So we have to see the due date, whichever is having minimum, we have to take that first, followed by the other jobs. So accordingly, we have to select the sequence. And we have to do the same whatever we have done. So in this, if you do, you'll be getting processing time similar 40. Then we'll get flow time this 116, but this average lateness is 44. And then this all the parameters. I'm just writing. This is the process we do, and the calculation of this all the four parameters will be similar with the other model also, that is last in first out. So we will take the reverse order, that is EDEC EDC BA, and we'll do the similar process. Okay, let me write everything at once so that you will see the difference of what happens in each rule. Average completion time, U is the utilization, average job waiting in the system, and average job lateness. Okay, first let me take SPT. So actual completion time we got as 22. Utilization is 36. This is in percentage, 36.3. Whereas LPT we got is 13. So FIFO is like in between this SPT and LPT. Then comes the earliest due date. So it is 23.2, 34.8, 2.9, and 8.8. And then the others, late LIFO also, last in first out, 23.8, 33.6, 2.9, and 12. And then we have one more system also, that is random. So these values different, each person will get to say different values. Like the sequence will depend on each person. Whichever sequence you like, you can take. It is like a priority based. So if you see this utilization, whichever is higher, SPT is like the highest in utilization. Then when it comes to this average delay, so we are getting it is earliest due date as the minimum average delay. So this is the difference you can get, as well as this average job waiting time in the system also less in case of SPT. So this is the difference you can see between the different types of rules that we follow. Suppose if you want less job waiting time, then you have to follow earliest due time. But I want good utilization and average job waiting time, then I will follow SPT.
Sir,
Yeah.
SPT rule gives the maximum utilization time for the every problems, like for this problem only.
Yes, yes. No, it will give to every problem, na?
Okay.
Yeah, it is applicable to everywhere there.
Sir,
Yeah,
sir, utilization is total processing time by total job flow time, sir. And this is inverse of it.
yes,
Average job waiting.
yes.
Okay.
But these models are sufficient, okay? But so many models are there, like 12 or 13 models.
Yes, but these are the main models. Only SPT, earliest due date, LPT. These are the three important models that you should know.
Okay.
Yeah. But there is some problem with this SPT because this average job waiting time is more compared to ETD. That is the only drawback in SPT. So these are the comparison I am saying. But if you see first in first out, so whoever is coming first, they are getting the fastest service. So it will get some customer goodwill compared to the other process. These are the some conclusions that you can draw from this. So there is one more method. I'll discuss. That is, these are the some of the rules that you have to follow. Then we have scheduling by critical ratio. So this critical ratio is nothing but due date minus today's date divided by workdays remaining. So in short form, okay, this is the critical ratio. So for this, the input, whatever the parameters required, they will give. They will give the today's date. They will give the this due date. Then you can accordingly calculate the what is the work days remaining. Simple example. Today's date is given as 25th day, and I have some jobs. So the due date is 30, 28, 27. Work days remaining 452. So accordingly, we will calculate critical ratio, and we will schedule according to that critical ratio. In first case, we will calculate critical ratios for everything. So now in this case, we will get 30 minus 25 by 4. Similarly, we will do for the other systems also. Then we will see the whichever is having minimum critical ratio. So we will select that thing. Yeah, so there are some. You have three different values of critical ratio. One is 1, the less than 1, equal to 1, and greater than 1. So here the critical ratio is greater than 1. If it is greater than 1, it has slack time, means it has enough time to delay. Okay. Then if it is less than 1, it indicates that it get delayed. Suppose it exactly equal to 1, it is like on time. Okay, this is one. So according to this, can you tell me what is the optimal processing order?
One three two.
132. Suppose let us follow 132. So 1 is having greater than 1, means it has slack time. Slack time is like I have time. I don't have any
2, 3 1, sir.
hurry. So I will not keep 1 here. If possible, I'll keep at the end. So first one should be given higher priority of less than 1, because it is getting delayed. So I will take 2 first. Then it has slack time, so I no need to worry. So I will take the third one because it is on time. Then I will take the final one because it is having slack time, so I have no hurry to finish the job. Okay, this is a uh, optimum processing order will follow in this case, and the rest will be similar. So now let me give some examples. Yeah, you can attempt this question.
Sir,
Yeah.
is it 28.5?
Okay. 28.5.
Thirty-three point five.
Okay.
Sorry, sir, I'm getting 31.
Okay.
Yes, sir. 31 correct.
Okay. So, see this keyword, shortest possible average flow time. Okay, let us solve. So we have PQRS, but we have to arrange so shortest possible average flow time. Okay, so which will give shortest possible average flow time? So it is nothing but this average flow time that is summing up uh, total flow time. It should be the highest one, or this value. Okay, ACT should be the highest. Here I didn't, no, not the ACT one. We have to see each individual, these values, 121. Let me come from the first one. So here I got, which is one day, SPT. I got 110. Okay. Then the other one is longest processing. I got 130. So 110, 130, then 121, then 116. So which is having, so SPT is having 110, 130, 113, something 120, something earliest due date, 116. So which is having the minimum, right?
Yes.
Right? So we have to apply SPT. So if you are confident with that, then you can proceed easily. So first thing first is arrange the job sequence. So I can arrange that. I can directly write this processing time column, which is 9, 12, 15, and 22. Then I no need to worry about the job sequence also now. Then I will directly go to this flow time. That is 9, then 9 plus 12, 21, 21 plus 15, 36, 36 plus 22, 58. Total I am getting 124. So they are asking the shortest possible average flow time is in days. So we have 124 total. Then we'll get, there are 4 jobs. We'll get 31 days. Any doubt in this question?
No, sir.
Yeah. Then we can proceed to the next one.
$19.5.
Okay. Nice. What is this 19.5? They're asking you the
Sorry,
number
sir,
of
I missed.
delayed, right? Okay.
Three jobs delayed.
Yeah. Okay, there are some more questions also. I just solved two small questions. There are more questions also we can go through, and you can apply the same principles. So now I'll end with this concept, this Johnson's rule that I'm discussing earlier. So when we come, yeah. So when we are dealing with this three type of mission, so generally this rule is followed for simple solution. If this any this is or so any one you can even if one is satisfied, you will get a simple solution. But if is none is satisfied, you'll end up with multiple. You can still follow this method, but you'll end up with multiple sequences. Okay, you try to complete this thing with the two different sets and see whichever is giving the optimum, and you can check the respective times. Okay, so because we got a tie in this 26, so we one sequence we went with this 31 option, in other we went with 30 option. See which is giving you the least processing time or average processing time, whatever. Then accordingly you can make out things.
Sir, but we can break the tie randomly.
We can break the
Tie randomly also.
yeah, we can try randomly also. No, if in the question if they specify you certain particular thing, then you have to go with it.
No,
So
sir,
in this
actually,
type of
tie, sir. I meant the tie actually. Like when we have the same processing time for two things. 26
so we will
phases.
so we get the tie. So I explained like we'll get two types of sequences. You have to follow up, solve the both and see whichever is giving minimum and follow that sequence. Sometimes we see these values of the other machine also, but this is the like straightforward answer. But I think there is one question previous years where they have given three missions, but in that case they have given you the sequence. So the sequence is given to you. So you just have to do this thing very carefully without any numerical error, but then draw the tabular column neatly and solve it so that you'll not do any mistakes. They'll just ask you these three only. What is the total flow time? Total thing, then number of jobs delayed. Okay.
Sir, always mission A equal to mission 1 plus mission 2.
Yes, yes.
For always.
Yeah, this is always the case.
Sir?
Yeah.
Sir, can you kindly explain this table for three machines? Like which you should have.
Thing is similar. So we'll have a job sequence here. We will have in time, we'll have out time. So that out time will be carried out here. And we'll add the time for that certain job in machine 2. Suppose in this case, this is 12, 12 hours in this time. So 10 plus 12 will get 22. And similarly, this job will get loaded to the next machine. And it will complete by 36 minutes. Meanwhile, the other job will get loaded in the second machine. Okay, and the sequence continues. So only thing you need to take care is we have to see the values, this out time and these values. Okay, here. Suppose if you have say simple example, I have a machine 1 here, I have a machine 2 here. Okay, some jobs are going randomly. So, but what happened is, so the job in the suppose I am taking some job J, so the job is completed by same 10 minutes. Okay, but there is one job, say job 2 and job 1. Job 2 is going on in machine 2, but it is taking me 12 minutes. So the next job, that is this J2 will go out, then this J1 will come to this M2 machine, this J2. It is completed in this and it is going to M2. So then I should not take 10 minutes as the input for the machine 2. Instead, I have to take 12 minutes because that time the job is not vacant. It is still doing its job. Okay, that's 2 minutes is nothing but a delay, like ideal time.
So we are choosing a maximum out of the out times.
Yes, exactly. Yeah. In some sense, maximum. This is the like concept behind that. You have to take the maximum. 22, 22, 22, 21. You have to take the maximum 22 here. Similarly, in this case, 48, but here it is 51. So I have to take 51. In this
So
case, the concept is reverse. Yeah.
in the second row, actually it is 35. So,
Yeah, this is 35.
and that is maximum. So next one should be 35 minutes.
No. But this job is doing some job till 36th minute. It is not free. So that 1 minute will be like this machine 2 has to wait. The job has to wait. I just explained one thing, right? It can be the other thing also, right? So in case of 10 minutes, it is taking 12 minutes. But the job in other case, it is finishing in 10 minutes only. Okay, and 2 minutes it will wait till this job 1 will come to this. So it can be the both the ways.
Yes.
Yeah, that's it for now. We'll see in the next class then.
Or in critical ratio in scheduling.
Yeah. Yes.
Work days remaining for the job 2.
This 0.6.
Today's date 25, but due date 28.
Yeah.
How 5 work days remaining?
No. This work days are given to you. Okay, this column will be given to you. This column and these values will be given to you.
Sir, in first problem, 2 missions, 2 jobs, you given as a homework.
Yeah. This one.
The idle time on the mission 2 here mentioned 11.
Yeah.
But mission B starts when after the 10 minutes of the mission A.
Okay, yes.
So 10, 11 plus 10 also included or not?
11 plus?
Plus
Is
10.
the ideal?
Yes, sir.
This is the ideal time that I am talking. You have to add these things.
For idle timing of that mission A, mission B only, not
Yes.
for the total entire ordering of the unit.
Of course, it can be the entire one, but this specially for machine 2 because machine 1 is always filled. There is no idle time for machine 1. For this system, you can say system idle time also 11, you can say.
No, sir. System idle time 11 plus 10.
11
Permission to 11 for system 11 plus 10.
Where is the 10 coming from?
In the Johnson sequence, first job is ordered by 2.
This is the Johnson sequence.
For that problem, sir. Even homework problem
Yeah.
that.
Similar, same thing happens. So you are getting some 10 minutes delay for machine 1.
After mission working with 10 minutes, after the job mission B is started.
Okay,
sir.
you are taking this initial time. Okay.
Yes, sir. Yes,
Yeah,
sir.
you no need to consider that. Okay, if you consider total, yeah, you are correct. For if you consider total system idle time, then you can consider that value.
Okay. For mission 2, it is the idle time is 11. For the whole system, the idle time is 21.
Yes, yes. But in general case, we won't consider this delay. But still, that is the logical thing. 21 will be the correct one. Because, yeah, 21. If you follow that sequence, then you'll get that this value for that question. Okay, then, yeah. Thanks for attending. We'll see you.
Sir, we have any next session, sir, in between the exam?
Actually, the exam, these sessions will go on, but you can carry on it with your own work. Okay.
Sir, which means for next year, sir?
Yes, yes. For other users who are willing to give in the next year, something like that.
Okay, then it will be continued till the 24.
Yeah, it will be complete. It will. There are 2 more sessions. Then they will take some gap. Then they will start again.
Okay, then it might be started on like April or May, right?
Yes, yes, correct.
Okay.
Whenever they will. Okay.
And will you take the metrology or like any other different classes, or like
Actually, it
it
depends.
hasn't been?
It depends actually. So
Okay.
whenever they float the form, then we have to decide within ourselves.
Okay. Thank you.
Yeah. Thanks. Thanks for attending.
Ah.
Thank you, sir.